Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to predict the charges on monatomic ions. So let's get into this. So the first thing you need to know is that all atoms want to have a full outer shell like the noble gases. The noble gases are not very reactive because they have all the electrons that they want, meaning that they have a full outer shell, a full valence shell. And that is what other atoms want. They want to be stable like the noble gases, so therefore they're going to want a full outer shell, and that is usually going to be 8 electrons, sometimes 2. So if you are going to be like helium, then helium only has 2 outer electrons or 2 electrons in its outermost shell. So for those elements that are close to helium, they're going to want 2 electrons in their outermost shell, not 8. But all other atoms are pretty much going to have 8 electrons or 8 valence electrons. And so that's what makes them stable. That is what is considered a full outer shell. Again, helium has a full outer shell, but it only has 2 electrons, as you can see in the inner shell here. 2 is the max, and so therefore, if your outer shell is only the first one, then you're going to be full with only 2 electrons. Also, so therefore, all other atoms are going to lose or gain electrons to be like the closest noble gas. So whatever noble gas is closest to that element is going to be want to be like that noble gas. So here are some examples to kind of clarify and explain what I mean by this. So here I have 6 different atoms. Here I have 3 nonmetals on the right side of the table. And here I have 3 metals on the left side of the periodic table. And the first thing I want to point out is that all of these are in the same period. They're in period 3. How do I know that they're in period 3? Because they have 3 energy levels. All of them have 3 energy levels. So if you know your periodic table, you know that the period of the periodic table indicates how many energy levels those elements have. And so since they all have 3 energy levels, or 3 shells, or 3 orbits, or however you want to indicate that, that indicates, oops, sorry about that. So that indicates that they're all in the third period. Okay, so that's the first thing. Second thing is, notice that they're in their valence electrons. The valence electrons are the electrons in the outermost shell. So this third shell or third energy level is the valence shell. And so you'll see that chlorine has 7 valence electrons, 2, 2, 2, and 1. That's 7. And then also remember that the group number, the A number, for the group, we're talking about the main group elements. So A1, A2, or 2A, 1A, 2A, 3A, 4A, all the way to 8A. That number, that group number, corresponds with the number of valence electrons. So since chlorine has 7 valence electrons, therefore it's in group 7. Oxygen here has 2, 4, and 2 here. That's 6. So 6 valence electrons, that's in group 6. Nitrogen has 5 valence electrons, 2 here, 1, 1, and 1. So nitrogen is in group 5. Same thing over here. Sodium has 1 valence electron, it's in group 1. Calcium has 2 valence electrons, it's in group 3, or group 2, sorry. And aluminum has 1, 2, 3 valence electrons, it's in group 3. So the group number corresponds to the number of valence electrons. Okay, so that with that out of the way, let's talk about these 3 here. So since chlorine wants to be like its noble gas, remember, so all atoms are going to lose or gain electrons to be like the closest noble gas. Our closest noble gas is number 18. So let me write this down. So this is number 17, number 16 on the periodic table, and this is number 15 on the periodic table. And argon is number 18. So chlorine wants to be like argon. Argon is the closest noble gas. So how is it going to be like argon? Well, it has 17. It's number 17 on the periodic table. Therefore, it has 17 protons and 17 electrons. So it wants a full outer shell. So it's going to gain one more electrons to be like argon. Notice argon is number 18 with 18 electrons. So to be like argon, chlorine just needs to add one more electron to have 18 total and to have 8 in its outer shell, just like argon. Notice argon has 3 rings, three energy levels, 3 shells, and it's got 8 in the outermost shell, in the valence shell. So all chlorine needs to do is gain one electron to be like argon. So now it gains an electron. It's now like argon. It has a -1 charge. Okay, so you can predict what the charge is going to be on chlorine by thinking about, okay, what's the closest noble gas? In this case, argon. Argon is number 18. Chlorine is number 17. It needs to pick up another electron to be like argon. So electrons are negative. It picks up one negative electron. Therefore, it's going to have a -1 charge, right? Same thing with oxygen. Oxygen is number 16. The closest noble gas is, again, argon. So it's going to want to fill in its outermost shell, and it needs 2 more electrons to do that. It needs 2 more electrons to get 18, and it needs, again, 2 electrons to fill in the outermost shell with 8. So it picks up those electrons, and now it looks like argon. And because it picked up 2 negative electrons, it's going to have a -2 charge. So that's how you can predict the charge on oxygen. It's 2 away from argon. It needs to pick up 2 more electrons to be like argon. So therefore, it's going to be a -2 charge. So finally, with nitrogen here, number 15 on the periodic table. Again, the closest noble gas is argon, 18. And so it's going to want to pair up. It's going to want to add 3 more electrons to get 8, and then to have 18 total. And so it picks up those 3 electrons, and now it has an electron configuration, or it looks like argon. So notice that all 3 of these look like argon in their electron configuration, and the way that the electrons are organized looks just like argon, except nitrogen now has a -3 charge because it gained 3 negative electrons. So that's how you can predict nonmetals. For the metals, same thing applies. So the closest noble gas for these 3, sodium, calcium, and aluminum, is neon. So since the metals are on the left side of the table, they got to go backwards. They got to lose electrons to be like their noble gas. So nonmetals being on the right side of the table, they're going to gain electrons to be like their noble gas. Metals that are on the left side, they are going to lose electrons to be like their noble gas. The closest noble gas is backwards. So sodium, or neon here, this is number 10 on the periodic table. Sodium is number 11. Here, let me write it here. Sodium is number 11. Calcium is number 12. Oops, that's 20. Let me hold on a second. That should be not calcium, magnesium. Number 12 is magnesium. And then number 13 is aluminum. So the closest noble gas in this case is neon with number 10. So they got to lose electrons to be like neon. So sodium, number 11, has to go back to number 10. It's got to lose an electron. Right now it has 11 electrons. Now it wants 10, so it's going to lose an electron. Notice that it's only got one electron in its outermost shell, in this valence shell. So if it loses that electron, then the next shell available is full. That's going to be the second shell. It's got 8 electrons. It's full. So then sodium will have a full outer shell, just like neon. So it's going to look like neon. So it's going to lose that electron, and then it's going to have a +1 charge. So in this case, it's losing one negative charge. So it's going to become +1. Losing a negative means that you're going to be positive. Why? Because remember, you've got 11 protons here too, and 11 electrons. If you lose one electron, then you'll have 10 electrons and 11 protons, and so you got an extra proton. That's your +1. Okay, so then you've got Na+. So with the magnesium, it's got 12 electrons. Notice it's got 2 electrons in the outermost shell. It's in group 2. So remember the group number, the group A number corresponds with the number of valence electrons, the 2 electrons in the outermost shell. So in this case, to be like neon, it's going to have to lose those 2 electrons. So it loses 2 electrons. And then that shell is now empty, and the next shell is full. So now it looks like your looks like neon. And again, this is not calcium, but magnesium with a 2+ charge. So there you go. And then finally, you have aluminum, number 13. So it's got to lose 3 electrons to have 10. So if it's going to be like neon with 10 electrons, it's got to lose 3 electrons. Oops. And so notice it has 3 electrons in its outermost shell. It loses those 3 electrons, and then you've got a full outer shell for the next one. So now it looks like neon. So all 3 of these look like neon. So sodium loses 1 electron, gets a +1 charge. Magnesium loses 2 negative electrons. It's going to have a +2 charge. And then aluminum will lose 3 electrons. It's going to have a 3+ charge. And so that is how you can determine the charge based on what the closest noble gas is, and then figuring out, does it need to lose electrons to be like that noble gas, or does it need to gain electrons to be like that noble gas? So that's how you would predict. Now, there's an easier way to figure this out. Sorry about that. Now, I wouldn't say an easier way, but it's a way to help you remember. If you can remember this is the best way to figure out and predict what the charge is going to be on your monatomic ions. But there's a kind of a couple of rules you can apply as well. So over here, you can see that I have this box written here, and this is kind of a shorthand, easy way to remember. So if you're talking about groups 1A through 3A, 1A, 2A, and 3A, then the positive charge on the ion is going to be equal to the group number. So notice over here, so sodium is in group 1. How do I know? Because it's got 1 valence electron. It loses 1 valence electron, it gets a +1 charge, the same number as the group number. Magnesium is in group 2A, so because it's got 2 valence electrons, so it's going to lose those 2 electrons and get a +2 charge. So the group number 2 matches with the +2 charge on the magnesium. Same thing with aluminum. Aluminum is in group 3A. It's got 3 valence electrons. It's going to lose those 3 electrons, get a +3 charge. So its group number matches the positive charge on the ions, and that's for all the ions in that group. Okay. For the groups 5A through 8A, the rule is a little bit different. It's going to be the negative charge on the ion will be equal to the group number minus 8. So if you subtract 8 from the group number, you get the charge. So over here again, chlorine is in group 7. It's got 7 valence electrons. It gains one more electron, gets a -1 charge, right? So what is 7 minus 8? The group number is 7 minus 8 gives you a -1. Okay. Oxygen, group 6. So it's got 6 valence electrons. It gains 2 electrons to have 8, like its noble gas, argon. So then it has a -2 charge. So that matches with the rule here. So group 6 for oxygen. Oxygen is group 6. So 6 minus 8 is going to be -2. So that's the charge on oxygen. And then finally with nitrogen, you get group 5. So nitrogen group 5, 5 minus 8 is -3, just like what we saw here. So it gains 3 electrons to be like the noble gas, so it has a -3 charge. So you can remember, you can use this to help you remember what the charge is going to be for your monatomic ions in the main group elements. This only works for main group elements where the group number is the A group number, 1A through 8A. So you can't apply these to transition elements. It won't work for the transition elements, only for the main group or representative elements in the periodic table. Okay, so well, what about hydrogen, right? So hydrogen, hydrogen is group 1. It's going to gain 1 electron, right, to be like helium. So helium, so if this is that is the atom of hydrogen with 1 valence electron. So helium is a noble gas. It has 2 valence electrons for a full shell. And so this hydrogen will gain an electron, gain 1 electron, and it will have now 2 valence electrons. So this will have a minus charge, H1. So it would be a hydride ion. So that's what the tendency would be for hydrogen. It wants to be like noble gas helium, so gain electron and get a -1 charge. Okay, so that is how you get the charges, or you can be able to predict the charges on your monoatomic ions for the main group elements. I hope this was helpful. If you enjoyed this video, then please like the video, share the video with your friends, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a particular question you want me to answer and help you with, or if you have a topic you want me to cover, then please let me know. I would love to do that for you. Thanks for joining me, and have a great day.